Hello, everyone, and welcome to the Math Bender. This is the first session on logarithmic series. So let's start. Let's say if I write something like this, this means how many times do I have to multiply 2 in order to get 8? I'll multiply 2 3 times to get 8. So the answer to this is 3. The same way, if I write log 10 of 100. Now, how many times do I have to multiply 10 in order to get 100? So, I'll have to multiply it 2 times. So, the answer to this is 2. So, logarithms are inverses of exponential functions, and 2 to the power of x is equals to 8. It's pretty straightforward. What you do is you convert that 8 into base of 2, and you can easily write it as x is equals to 3. But the problem comes when I write 2 to the power of x is equals to 7, because mentally we cannot process what is 2 to the power of x that makes the number 7. And this is where we apply logarithms to bring that power down. So if we have a situation like this, 2 to the power of x is equals to 7, what I'll do is I'll apply logarithms both sides. And in this scenario, I would want to apply log base 2, because 2 to the power of x and log 2 are inverses of each other. You need to keep that in mind, that log can be of any number, of any base or any type. So there is no problem whichever log that you're applying. I would recommend that whatever the base here is, you apply the same type of log, so that you need to bring it down. So here I'll write log 2 of 2 to the power of x is equals to log 2 of 7, and hence log 2 of 2 is going to be 1 because they are inverses of each other. X is equals to log 2 of 7. Now log 2 of 2 is as same as log 3 of 3 is as same as log x of x, or log 100 of 100. They are all equal to 1. Let's see. If I write log 100 to 100, and I'll see that it is equals to 1. So you can try using your calculator. Keep that in mind, that this is the button that you would require in your calculators if you're using Casio 991EX. You write the base. Let's say I write base 2 here, and I write that number 2. And when you equate it, you get 1. The same way, I'll call this as my rule 1. Although there's no rule, it's just that you'll remember it anyway. Log 2 of 1 is equals to log 3 of 1 is equals to log x of 1 is equals to log 100 of 1. Any of these you can apply on. Any log compared with 1 is going to be equal to 0. So you can remember it as your rule number 2. Now let's look at some of the questions and we can check. So let's say if we have a question where I have to write 10 to the power of x is equals to 0.06. The first thing that you need to notice is that this here is the base, and this is the log model that you'll apply both sides. So I will apply log base 10 both sides. And this will become log 10 of 10 to the power of x is equals to log 10 0.06. Hence, as I said, that rather than getting into details because you've already cleared the concept, so you can straight away multiply this here with x and you will be left with log 10 of 10, which is 1, is equals to log 10 of 0.06. Hence, you've converted that into log form. All of the above questions are in base 10, so they're all going to be converted the same way as we just did. So you may try solving rest of the questions on your own. You may write in your comments if you're not able to solve any or you may need help. The next thing here is I see 4 to the power of 3 is equals to 64. So as I said that this is the base. So I'll apply log 4 both sides. And if I apply log 4 both sides, I'll see that log 4 of 4 to the power of 3 is equals to log 4 of 64. And 3 is equals to log 4 of 64. You can check that too. If I write log 4 of 64 here, this is equals to 3. Now, moving on to one more example from here. A to the power of b is equals to c. A lot of students do tend to get confused if they see too many variables, too many letters in a question. So this is the base. I'll apply log a both sides. And once I apply log a both sides, I'll see that log a of a to the power of b is equals to log a of c. And hence this multiplies and become b is equals to log a of c. Hence you've converted that into log form. Now let's see if we have a question like this. I'll solve just one question. So 10 to the power of x is equals to 720. I need to find that value of x. This is what solve means. But in order to find x that is in the power, I cannot convert that into this number into 10 to the power. So hence, the first thing that you should think of is applying log. The next thing, which log model would you apply? So as I said that this is the base 10, so which means you'll apply log 10 both sides. So when you apply log 10 both sides, this will become log 10 of 10 to the power of x is equals to log 10 of 720. Now x, since you know that this multiplies, x is equals to log 10 of 720. Now just simply plug it in your calculators. Log 10 of 720 gives you 2.85733, a big number, but the answer is required in three significant figures, so it will be 2.86. I just rounded that off. Let's move on to another example. Now converting from log to the exponent. Now LGX is equals to 7.5. Now note that wherever you see LG, it is as same as log base 10. There's no difference. It's just a different way to write it. So you may see where somewhere it is written as LG, somewhere it is written as log base 10. Whichever you like, that's okay. So whenever I want to convert this, so since as I mentioned before that log and exponentials are inverse of each other, so hence I can write this as apply 10 to the power both sides. And you can say that 10 to the power Lg to x is equals to 10 to the power 7.5. X, since 10 to the power and Lg base 10 are inverse of each other, they cancel out. 10 to the power 7.5 is the final answer. One more thing to understand here. If you want to remember, this is the mathematics behind it, but if you want to remember it and understand it in an easier way, you can try Lgx is equals to 1.7, and when you take the anti-log, send it over there, leave this as it is x here, and whichever log model is there, just write that in 10 to the power and 1.7. Alright, so if we look at another example, log 2 of 4 equals to 2. So since it's model log 2, 4 equals to 2 to the power of 2. Let's say log 8 of 2 is equals to 1 over 3. So 2 remains here, and log base 8 go there and become 8 to the power 1 over 3. So if we have log a of b is equals to c, this b remains here, a goes over there, become as the base of, and c becomes the power. Now without using calculator, if we have to evaluate this, so first step, log cube root of 10, I can first write this as log base 10, log 10 of 10 to the power 1 over 3. I can write that too, since 1 over 3 will multiply, and this will become log 10 of 10, which is equals to 1. So we'll be left with 1 over 3. Let's say if I have a situation like this, I can write this as 10 to the power of 3. I can write 1000 as 10 to the power 3 over 10 to the power half. 10 to the power 3 times with, if I can write this as negative half, and this will be 10 to the power 5 over 2, and this will become 5 over 2 log 10, and Lg10 is as same as log base log 10 of 10, which is equal to 5 over 2. Let's see a question like this. There's a logarithmic form already given, and you're to solve it. So the first one, now here please remember that log 3 of x is equals to 1. Let's say if I have a situation like this, I cannot write this as 1 over log 3. This is wrong, because log 3 of x are not two separate functions. This is just one function. If I have to separate them, then I have to take the anti-log. So the same way, log 3 and this inner here is attached to it. So I'll write this as log 2 of x is equals to, now if I send this, take the anti-log, this will become 3 to the power of 1. And I'll write this as log 2 of x is equals to 3. And now taking again anti-log of 2, so x is equals to 2 to the power of 3. Taking this over there, x is equals to 8. Now if you could just pause the video for a while and try solving this question on your own. Log 2 of log 5 of x is equals to c. Now log 5 of x is equals to, when this be taken as anti-log, this becomes 2 to the power of 2. Log 5 of x is equals to 4, and when this is as well going there, so this is going to be 5 to the power of 4. So x is equals to 625. So this was it for the first session of logarithmic. Until we meet again on logarithmic sessions and laws of it, take care. Bye.